What do you mean by routing algorithm? So what is the basic function of network layer? The basic function of network layer is to route the package from source machines to destination machine, and that means from source host to destination host or node. So you have to route this packet. So routing of this packet will be taken care of the network layer. So network layer software is responsible for the same, and for that purpose we are designing the algorithms. So the packets can be transmitted by three methods. First one is the datagram, second one is the virtual circuit, and the third one is the session routing. Okay, now what do you mean by datagram? It requires the competition of decision making tables for each packet. That means whenever you are sending the packet, that packet you need to calculate, and depending on that computation you need to update your table. Virtual circuit, the routing decisions are made only when the new virtual circuit has been set up. That means whenever you are setting up a virtual circuit between the source and the destination, then the routing decision will be taken care of. And session routing, the data packets follow the same routing of the for the entire session. So we'll see one by one in detail as we proceed further. Okay. Now there are two concepts: routing versus forwarding. Routing means filling and updating the routing table. Okay. So routing means you are filling and updating the routing tables at various nodes or the networking devices. And forwarding means making the decisions which routes to the based on the routing tables. That means let us consider that if here it is a host A and which is connected to a network N1, let us call it as N1, and through router R1 it is connected to network N2, through which a source or destination is connected, let us call it as a B. So routing means so here it will consist a table, here it will consist a table which is the next destination. So you want to deliver it to B, so destination is B, and what is the next hop? Next hop is R1. So this is what the routing table for A. What will be the routing table for B? R1. The routing table for R1 will be, it will be delivered to B and there will not be any, because it is directly connected to this. Or if any other next hop is there, then in that case next hop will be there. Okay, so this is how, so whenever it will be changed, so these tables get updated. As we have already seen in previous case, the tables gets updated, and the method is called as a routing. Now making decisions, forwarding means making the decision which routes it to the use based on the routing tables. So it will take the decision, okay, which route it should take for this one, then that route will be followed and the packet will be forwarded to R1. So this is called as a forwarding. So decision making is based on this table. Then another algorithms are there. So adaptive and non-adaptive type of algorithms. Non-adaptive algorithms means routing decisions are based on pre-computed measurements or estimates and do not update the table based on the current traffic and topology. That means if this path is fixed one and this is also fixed one, it does not get updated. It does not get updated with the current traffic and topology. Whereas adaptive algorithms change the routing decisions and reflect the changes in the topology based on traffic. Okay, based on traffic. So this is how actually your data gets transmitted and all the algorithms are updated. Now there are two types of routing tables are there. First one is the static routing table and second one is the dynamic routing table. Now what do you mean by static routing table? A static routing table contains the information which is entered manually. This is very important. So you have to enter the information manually. So administrator of the network enters this route to the destination into a table, and a table is created and it cannot be updated automatically when there is a change in internet. So the table has to be updated by the administrator, and the administrator has the right to change it, and the content will not get changed automatically. A static routing table can be used in a small internet and it does not change very often. So it is a static. Static means it does not change. Whereas dynamic routing table, the dynamic routing table gets updated periodically by using one of the dynamic routing protocol called as RIP, SOPF or BGP. So these are the dynamic protocols which updates the routing table, and routing tables protocols are updated all the tables in the routers automatically. This is very important. So after certain period the table gets updated automatically. So all the routing tables of all the nodes will get changed automatically. Now what are the common fields that are used in routing table? What are the common fields that are used in routing tables? So routing table may contain the information called as a mask. It may contain the information network address, next hop address, interface, flag, reference count, and the use. Now what is the mask? The mask we have already seen that. So whenever you are using a classless type of addressing, then in that case you mention the IP address by /n method. Okay, so this will give you the masking information. So whenever you are using a classless type of IP addressing or logical address is given, then in that case this mask will help you to identify okay which network it belongs to. So this information will be given by this masking. So this mask is necessary. Then network address is there. Then next hop address will be given. So network address, it is the network address, it is the destination address where the packet is finally delivered. In case the host specific routing, it defines the address of the destination host, and if it is a network specific, then in that case it is a it defines the network address. Okay, then next hop address is the address of the next router where the packet has to be delivered. That means from A to it goes through the network to R1, which is a router 1. So the address of R1 should be mentioned over here. The address of R1 should be mentioned over here. Okay. Now the next one is interface. This field shows the name of the interface. So there are different types of interfaces that are used in networking. So these interfaces are mentioned over here. So depending on that, the interfaces are mentioned. Then there are flags. 5 types of flags are there. So these flags are updated depending on the presence of the data or absence of the data. So what is that? So first flag is U, that is up flag, G gateway flag, H host specific, D added by redirection, and M modified by redirection. So these flags are get updated. What do you mean by U? So U flag indicates the router is up and running. That means router is in working condition and it is running. So if the flag is not present, it means that router is down. and the packet cannot be forwarded, and here the packet gets discarded. Okay, so up means it is in working condition. G, the G flag means that the destination is in another network. So the G flag, if it is set, then it will identify that the destination is in another network, and the packet is delivered to the next hop either by indirect delivery, and if it is in the same network, then this flag is 0, or it is not, this flag is missing, so this flag doesn't have any value at that time, so it is a direct delivery. So for direct delivery, G is reset, and for indirect delivery, G is set. Host specific, so H indicates the entry in the network address where the field is host specific. When it is missing, it is a by default network address of the destination, so it is a network specific. D means added by redirection, so the D flag indicates the routing information for the destination has been added to the host routing table by redirection message from ICMP. So it works along with ICMP. So whenever there will be some control, or control is required, or redirection is required, then in that case this flag is utilized. And again with ICMP, if you need to modify the information, then this yum bit is set. So along with ICMP, this information or this flag is associated. Then the reference count, this field gives the number of users of the router at the moment. How many users are there? So this information will be given by this information. So if 5 people at the same time are connecting to the same host from the router, then this column value will be 5. So how many hosts are connected to the router? So this count will be given by the reference. And the use is the field which is defined by the number of packets transmitted through this router for corresponding destination. That means how many packets you have transmitted to the corresponding destination. This count will be maintained by this use field. So whenever we are going to discuss now, henceforth, we are not talking about this, 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 we are also not talking about this. These two are very important for us, so we will be talking about these two. So henceforth we are going to discuss, whenever we'll talk about the algorithms, routing algorithms, then in that case our table will consist only these two informations. Apart from this, these informations are also available, but our focus will be on network address and next hop, or the distance that we may calculate it. Okay, so this is how the table is there, and it can be maintained by either static information or by dynamic method. Now there is one important principle that is called as a optimality principle. What does it mean? Optimality principle: if router J on the optimal path from I to router K, I'll explain it with the help of diagram also. If router J is on optimal path from router I to router K, then optimal path from J to K also falls on the same route, right? So let me draw it. What it says, this is, let us say, I will say it will be I. Okay, this is router I. Now let us consider that this is router J and this is router K. Okay. Now let us consider that this is the distance d1 and this is the distance d2. Okay. Now from this I to k, what is the distance? Total distance. Total distance d will be is equal to d1 plus d2, and this is the optimized path. This is the optimized path. Okay. So total distance will be, or the optimized distance will be d1 plus d2. Now what, according to this principle, if the router J is on optimal path from router I to K, that means this path will be considering, then the optimal path from J to K, from here to here falls on the same optimal route. Okay, so it is on the optimal route. Let us try to understand with the help of this diagram. Now, according to optimality principle, I and K, and if I want to calculate the distance between this one and this is the optimized route. This is the optimized route. So with distance d1 and with distance d2, then what happens? The total distance will be, or the minimum distance. Optimizing means the distance should be minimum. So what we will call it as a optimized distance. So d1 plus d2 is the minimal for optimal path. Then what this principle, optimality principle, says, suppose there is another path from J to K which is having distance d3. Now how the optimality principle will work, let us see. Now here you can see that whether d3 is greater than d2, yes. Okay. Now what you will calculate? You will calculate this path distance and you will calculate this path distance. Okay. So d1 plus d3. So this is d1 and d3 will get added. d1 plus d3 is greater than d1 plus d2. Then which is the minimum one from these two distances? So if I calculate a mean of these two, let us say this one as a capital D1 and let us call it as a capital D2. Then what is the minimum distance? So you will calculate the optimized path will be the minimum of these two. Okay, the minimum of these two. So it is obviously T2, that means D1 plus D2. Then this D2 also lies on the optimized path. This is what the optimality principle says. So set all the optimal routes. What you are going to do? So this is going to lead a concept called as a sync tree. What you are going to do? You are going to find out such nodes are identified in the complete network. You are going to find out all the sources to all the given destinations. You will be finding out all the optimal routes by this method, and a structure is formed. It is just like a tree structure, and this tree is called as a sync tree. So here you can see that this is a sync tree. So you can see this concept here. This diagram is a topology where all these nodes from A to N, O is the last one. So A to O are connected to each other by various distances or various routes. Now you just find out the optimized route for each node. So from A to B, B to C, here you will be calculating these distances, and the optimized route is found out, and these optimized routes are only considered to connect the nodes, to connect all the nodes. Now here you can see that F and H is also present, but this path is not considered because it is not optimum. G to L is not considered because this is not optimal. So optimality principle has been calculated, and accordingly a structure is formed and the tree is called as a sync tree. So sync trees are not necessarily unique one. So it should not be it may not be unique one. Okay. So goal of the routing algorithm is to discover the sync trees for all the destination. So you need to find out what is the optimum path through which you can send your packet. This is how you will be finding out your information and you will be sending the data. So this is the concept is called as a sync tree. Now we need to find out the shortest path routing, so which is based on the previous concepts. So what are the optimization criteria you will be considering? First, you need to consider the distance between the two nodes or the distance between the source and the destination. Then you need to calculate the bandwidth. You need to look at the average traffic on the network. You need to find out the communication for cost. You need to find out the mean queue length. You need to find out the what are the delays that are occurring because of the traffic and all the upper parts, bandwidth, because this we have already seen the concept of performance. So the bandwidth and the length of the cable, it is deciding the efficiency of the channel. So this is how you will be coming to the optimization criteria, and through this you need to find out the shortest path from one node to another node or the source node to destination node. So there are two types of algorithms those defined the shortest path route. First one is called as a Dijkstra algorithm and second one is a flooding algorithm. So we'll be focusing on first algorithm, that is given by Dijkstra. So what it gives you, it is a non-adaptive type of algorithm. So the distance is fixed, so the table is also fixed, it is not updated. So you need to update it accordingly. Now a given network topology, for a given network topology means the way the nodes are connected to each other. That may be anything, that may be a star, that may be a mesh, or that may be any other type. But so for a given network topology, a set of weights describing the cost to send the data across each link of the network. So let us consider, I'll give you the example. Now let us consider that this is node A and this is node B. Okay. Now I will calculate the distance, or you may call it as a cost also. So this distance is given by either 2 or 3 or 4. So these weights will tell you, okay, this is the cost to send the data across the from node A to node B. So 2 is the weight which describes the cost of sending data from A to B or B to A. So find the shortest path from the specified source to all the destination in the network. So you need to find out which is the shortest path from the source to destination, and how to find out. This algorithm is developed by E.W. Dijkstra. So how the algorithm works, let us see. Mark the source node as a permanent. So the source node will be a permanent node. You have to mark it as a permanent. So we will see when we will see the next example, we'll come to know that how actually this algorithm works. Then designate the source node as a working node. So permanent node is a working node. Now set the tentative distance to all other nodes to infinity. So initially set all the distances to the infinity except the adjacent one. Adjacent one means which are directly connected to the permanent and working node, except that all the distances are tentative distances and it is marked as a infinity. While some nodes are not marked as a permanent. Some nodes are not marked as a permanent. So we'll see how it is marked as a permanent or non-permanent. Then we will compute the tentative distance from the source to all the nodes, all the adjacent nodes or to the working nodes. As I said, so let us consider that here I'll consider this is node A, okay, this is node B, and this is node C, and this is node D. Let us consider this is the example. Okay, now A is connected to this, B is connected to this, B is connected to D, and C is also connected to D, but A is not connected to D. A is not connected to D. Now this is 2, this is 3. Now what I'll mention the distance? I'll mention the distance 3 comma A. So C's table will be like this. C will have a dimension 3A. 3A means 3 is the weight of this cost from A to C, and A is the adjacent node or the source node. Here you will write it as a 2 comma A. But in this case, here in this case you will be writing as a infinity comma A, because this distance is yet not known. कारण हा A जो होता हा वर्किंग अँड परमनंट नोड होता, B अजून वर्किंग अँड परमनंट नोड नाही, तो टेंटेटिव्हच नोड आहे. C is also tentative node and D is also tentative node at the infinite distance. So the distance to D from A is unknown. That's why it is mentioned as a infinite. Okay. So after that, if this is shorter than the current tentative distance, then the replace a tentative distance of destination and record the label of working node there. Now here it is, which is the shorter one. Now the 2 is the shortest one because 3 is greater than 2. So I will mark this B as a permanent node or working node. So this will become a dark. So this path will become dark path. Okay, so this is the final path I have decided. Now whatever may be the distance over here, so that distance you need to calculate. So that distance you need to calculate, and that distance is calculated. So I can see that now it is 3A because B is marked and B and D distance is known to me. So I can calculate 2 plus 1 is 3. So from A, D is 3 weights away from the A. This is how a simple calculation will take place. So examine all the tentative nodes in the graph which is given. Then you need to select the smallest value and you have to find out a new working node. So designate the node as a permanent node. Now let us consider the example. This is the shortest path example. We will start with this concept. Now here all the weights are already properly mentioned. All these weights are properly mentioned. Initially this value is given to you. Now A is the source. A is the source and D is the destination, or these are the destinations. Now you need to find out the shortest distance. How you are going to calculate it now? Now here it is the first step. Now here it is 2, here it is 6. This is 6, this is 2. So I will mark B as the next working station. So now here you can see that here it is mentioned infinite, here it is 6A, 2A, here it is C is infinite, and from where C is infinite it is not mentioned, so it will be a dash, F will be dash, H will be a dash, and D will be a dash, infinite dash, infinite dash, infinite dash. But B and D, B and G are known from the source, so that's why it is replaced by 6A and 2A from these measuring values or distance values. So 2A and 6A is there. Okay. Now here it is 2 and here it is 7. Now B is marked as a B is marked as, this is marked, okay. Now this is marked as a permanent. Now when B is marked, from B the two nodes goes out, or the two links goes out, from B to E and B to C. Now B to C is 7 and B to E is 2. So which is the shortest one? So shortest one is E. So E will be marked as a next working node. Okay. Now you just calculate it. Now here it is 2. Here it is 2. Now the distance at this is 4, and which is the immediate working node? Immediate working node is B and the source is A. So the distance from source is 4 and the immediate node is B. So this is how you have calculated the distance. Now you reach to E. Now you reach to E. Now E, you will find that here it is 1. Means this is 1. Okay. Now this is 2. Okay. So these 2 will only goes out. These 2 will already goes out, and there is no point in going back because B is already marked as a working and permanent node. Now from E, this is the shortest distance. From E, this is the shortest distance. So you will go to G. So you will go to G. Okay. Now this is 6 and this is 4. 6 plus 4 is 10. Now here you can calculate, this is 4. This is 6. Okay. Now you need to go accordingly. This is 5. Now this is 5 and this is 6. Which is the shortest one? E. So the distance from A is E is the shortest one, and by this algorithm, by finding out the shortest path, we came here through E. A is 5 unit long. So this is the shortest. So I will go for this one, and then from this path is discarded. So this path is discarded and this path is found out, and this is the next node marked as a working node. Okay. Now from there, here it is 3 and here it is 2. Here it is 3 and here it is 2. So this is the shortest path, and the next path, so this is marked as a next working node. This is marked as a next working node, and after that it will reach to this final destination D. This is how the shortest path is calculated. This is how the shortest path is calculated. Is it clear? So we'll stop here and we'll discuss the next routing algorithms in